Okay, so here again, it's just another standard deviation example. So first, of course, we have to get the mean, which is really part of the process of calculating the standard deviation. Okay, so how do you get the mean? Well, again, you just add up the data values together. This is all quantitative data. You add them all up, okay? And then you divide by how many data values there are. So if you were to add them up, what you end up getting is 60. And there's 12 data values, so you have 60 over 12 equals 5. So the mean is 5 for this data set. All right. What do you do next? Well, you have to subtract the mean from each data value. So we have 3 so we're subtracting 5 from each data value. Here we get 3. Here for these two we get 0, -1, -2 twice, and so on. And then of course what you do next is you square the data values. You square the difference, excuse me. You square these differences, and this is what you get. You know, some of these are going to be 0, some are 9, some are 1, that's okay. And if you were to add up these squares, okay, if you were to add them all up together, all right, what you would get is 58. Okay, I double checked my calculations. I'm pretty confident. I'm confident that's right. Okay, so you add them all up. Then what you do is, once you add them all up, you get 58, right? Now remember, this is sample data by assumption. I think I said that. Yeah, this is sample data. So what you do remember is you divide by 1 less than the number of data values, or the number of data values minus 1, in other words. So we have 12 minus 1 is 11, okay? So we have that. Then what's the variance? We have 58 over 11, right? That's the variance. Again, you just divide. Then you take the square root to get the standard deviation. This is what you would get if there are, when you round it to 2 decimal places. Again, you know, I did this in my calculator, so. Okay. Okay, I will post these notes as well. So I know, I mean, if you're not writing this down, that's okay. To me, what matters most right now is that, you know, you understand it. I will post the videos as well. You know, I've been posting videos, so on YouTube, that is. All right. Are there any questions on this? Okay. So now remember here we go. So now remember also, we have frequency tables, right? What we can do is we can get the mean from the frequency tables. We can also get standard deviation, and that's what this example is going to show. In the next example, I originally was going to let everyone try it, you know, on their own. I think, though, it might be better if we do it together. But anyway, let's do this one now. So 25 randomly selected students were asked the number of movies they watched, you know, the previous week on Netflix. If you don't know what Netflix is, just think of it as, you know, they just watched movies last week. That's all. And these are the results, how many movies they watched last week. Okay. And these are the results we got. So what we're going to get is the standard deviation. Notice it is sample data. For one thing, I'm telling you to find the sample standard deviation. Okay. Now remember here, you could list all the data out if you wanted. That's what I did here. But really, you shouldn't have to do that. For instance, how would you get the mean? Well, again, you take the number and you multiply by the frequency, right? You know, 0, for instance, you would list 5 times, as I do here. 1, you would list 9 times. 2, you would list 6 times, and so on. So instead of listing them and then adding, you could just multiply by the frequency. And that's what I'm doing here. And there are 25 there are The sample size is 25. I mean, that's from the word problem, but if you add up the frequency, that's just, you get the same number. So we get 37 over 25, which is 1.48. Now that's the mean. Okay. Now, I know that's not a data value, but again, it is the mean though. Okay, now what we can do is do follow the rest of the procedure for standard deviation. Okay. Here, notice what I did was I basically took the frequency table, but I interchanged the columns, numbers of movies and frequency, as you can see. These are the data values, right? You could also think of frequency this way. It's how many times the data value would be listed in the column, right? You know, for standard deviation, remember how we listed the data values like this? The frequency would be how many times it's listed in that column. Okay, so 0 would be listed 5 times. And for each data value, you subtract the mean. So you have 0 minus 1.48, which in this case is negative 1.48. Okay? 1 is listed 9 times. Each one of those differences is 1 minus 1.48, which is negative 0.48. And same thing for 2, 3, and 4. Likewise, that is. And here, of course, as before, we're squaring each of these differences. Now remember, with standard deviation, you have to add up the squares, right? Now, each of the squares is going to be listed according to the frequency. So this square would be listed 5 times. This one would be listed 9 times. So what we really do now is we take each square here, multiply it by the corresponding frequency, multiply by the frequency, multiply by the frequency, multiply by the frequency, and so on. Again, you know, it's almost like in this example, the frequency would be how many times that square is listed here. If we did the table this way, that's what we're doing. Now, what we do next is we divide by, remember there's 25 data values, right? But this is sample data, so we divide by 24. So here on top, again, we have the sum of the squares, multiply each one by its frequency and add up. All right. Divide by the sum of the frequencies. Well, one less than it, I mean. If you add up the frequencies, you get 25, but it's sample data, so we divide by 24. And this is what you get for the for the variance. Okay. The standard deviation, okay, what you would get is this. Okay, you take the square root. I mean here, oh, okay, there. I thought I forgot to round it, but here, rounded it here. So this is what we get here, though. Okay. Okay, are there any questions on this one? Okay. Originally, this one I was going to have everyone try, but I think it's better if we do it together. Okay. So this is actually a problem from the textbook. What we have is that 40 randomly selected students, they were asked how many pairs of sneakers they own. The results we wrote in a frequency table. So what we're going to do here is first we're going to find the sample mean. Using that, we're going to find the standard deviation. Okay. All right, so for the mean, well, it's just like before, right? You're taking each, okay, good. Thought that was a mistake. Take each data value, right? Multiply it by its frequency, right? Because again, that's the same as listing the data value according to its frequency, you know, listing it. So 1 would be listed twice, 2 would be listed 5 times. But instead of doing that, we could just multiply. So 1 times 2 plus 2 times 5 plus 3 times 8 and so on. okay? You know, you're adding up the data values, and how many data values are there? Well, there's actually 40, which is the same as adding up the frequency, as you can see. And so the mean turns out to be this number. Remember, with rounding, you only round at the very end. So I wouldn't round this. I would just round at the very end. I mean, what's nice is we have calculators and stuff that make the calculation a little bit easier. Okay, so we have that. So it's just like before, right? Just like the previous example. Again, I will post the notes, don't worry. So what we do is this. We take each data value, which is how many pairs of shoes we have, just like the previous example. Notice that we interchange the columns. I mean, you really don't have to do that. I just did it because I thought it would look better. For each data value, you subtract the mean that we calculated. Okay? Does someone have a question? No. I thought I heard the hand raise feature. My mistake. So what we have here is we have 1 minus the mean, 2 minus the mean, 3 minus the mean, and so on. And then you get the squares, as you can see. That's what we're doing here, right? You get the squares of each difference. I know it gets kind of messy, as you can see. I mean, personally, I don't like to round until the very end. I mean, if you were to round here, you want to make sure you have as many decimal places as you can handle to make your answer more accurate. You know, you don't want to get your answer wrong due to rounding. All right. Now again, in the last step where we add up the squares, you have to multiply each square by the frequency, by the corresponding frequency, because again, that's how many times it would be listed. You know, not each square is not listed just once. Each square would occur, you know, a different number of times. This square would occur twice. This square would occur 5 times. This would occur 8 times. You know, if you were to list them all one by one. As you can see, you multiply by the frequencies. That's what I'm doing. Okay? And once you do that, you divide by, remember there's 40 data values, but it's sample data. So we're going to divide by 1 less than that, and we get 39. So this is what we have. So this is the sample variance, and this is the standard deviation. Okay, this is what we get here. All right, are there any questions on this one? Well, okay, let me stop.